Hi class. In this segment we are going to look at ion concentration. And ion concentration will be important when we're considering solutions of ionic salts. And what happens, if you remember, when we take an ionic compound like copper nitrate and dissolve it in water, being a strong electrolyte, it dissociates into copper ions. We know that it's copper 2+ because there are two nitrate ions, and nitrate is NO3-, so the fact that there are two of them must mean that copper is 2+ charge. And it will dissociate into two nitrate ions. So how does this tie into concentration? Well, let's say we have a concentration that is 0.5 molar copper nitrate. If copper nitrate dissociates into a copper ion and two nitrate ions, we're going to have to consider the concentration of each of these ions separately as a result of the stoichiometry of this process. So for every one copper nitrate unit, I get one copper ion and two nitrate ions. So the concentration of copper ions, there's one copper ion produced for every one copper nitrate unit. So I will have a concentration of 0.5 molar copper ions. When I consider the concentration of nitrate ions, I have a ratio, a stoichiometry of 2 nitrate ions per every one copper nitrate unit. So from here, I end up getting a concentration of 1 molar with respect to nitrate ion concentration. And then the total ion concentration, sometimes we will report concentration noted in brackets. So if I say total ion in brackets, that means the concentration of the total ions would be the sum total, in this case, of the copper 2+ concentration plus the NO3- concentration. And here that's 0.5 molar plus 1 molar, giving me a total ion concentration of 1.5 molar. That means I have 1.5 moles of ions in this solution. And ion concentration is relevant for conductivity. So the more ions in solution, the more conductive that solution will be, the better conductor of electricity. It also influences colligative properties, which we don't dive into, but there is a Going Deeper section in the ebook if you want to explore it. But colligative properties are related to freezing point depression, so the more ions there are, the lower your freezing point will be for that solution. Let's take a look at some example problems where we need to account for the stoichiometry of the dissolution process when considering the concentration of a particular ion in solution. So the first one I have for you is, which of the following aqueous solutions contains the largest concentration of nitrate ions? One thing you need to keep in mind about concentration is that the volume does not matter. Whether I have 10 mils of a 0.4 molar solution or 100 mils of a 0.4 molar solution, the concentration is the same in those two species, just the volume is different, okay? So all my volumes given in this problem can be ignored, okay? So when I have 100 mils of 0.5 molar cobalt nitrate, this is going to dissociate to give 1 cobalt ion plus 2 nitrate ions. And so my total nitrate ion concentration is going to be 0.5, right? 0.5 molars cobalt nitrate. And we have a 1:2 ratio here to give me a 1.0 molar nitrate concentration, right? Then in the second option, B, 40 mils of 1.0 molar NH4NO3. So this would dissociate into NH4 plus. This is one of our exceptions to that metal-nonmetal ionic compound, and 1 nitrate ion. So the ratio here is 1 to 1. I don't need to work out that math. I will end up with 1 molar nitrate ion concentration. And then in the last example, I have 10 mils of 0.4 molar aluminum nitrate, and this will dissociate into Al3 plus cations plus 3 NO3 minus anions. So I have a 1 to 3 ratio here. So I have 0.4 molar aluminum nitrate, and it's 1 to 3, like I said, NO3 minus to Al NO3 3, so that cancels out. I end up with 1.2 molar NO3 minus ions. So the answer option C there, where we have 10 mils of a 0.4 molar aluminum nitrate solution, will have the highest concentration of nitrate ions in that sample. Using those same options, let's think about which of these would result in the highest total ion concentration. In the first option, I have 0.5 molar cobalt nitrate, and for every 1 cobalt nitrate, I produce 3 ions, 1 cobalt and 2 nitrate ions, so 3 ions. This will give me 1.5 molar ion concentration. Okay. When I do the same for the ammonium nitrate, I have 1 molar ammonium nitrate, and that dissociates into 2 ions for every 1 NH4NO3 unit. So that gives me a 2 molar ion concentration. And for the aluminum nitrate, I have 0.4 molar aluminum nitrate, and this is going to produce 4 ions, 1 aluminum and 3 nitrate ions, so 4 ions for every 1 AlNO33 unit. This gives me a 1.6 molar ion concentration. So the option B gives me the largest total ion concentration. And so we have to account for the concentration and the number of ions. It's not enough to simply say that aluminum nitrate is going to make 4 ions. It depends on that concentration, because this is so much higher. Even though it only produces 2 ions, the total ion concentration is much higher, and that will impact some of its properties like the conductivity and freezing point depression. If you have questions about ion concentration, please let me know. Thank you for watching.